Moving right along, we are on lesson 1.3 LCM. LCM stands for lowest common multiple, and it's a tool that helps us when we get to the point where we're adding and subtracting fractions. It's a tool that we'll use. Also is useful when you're in a situation where you need to create fair groups of things. You have a number of these, a number of chocolate candies, a number of butterscotch candies, and a number of orange candies, and you're trying to create fair packages that have the same amount of each type for everybody. How many packages can you make that have the fair amount of each type with using as much of those as possible? So if you're in a situation like that, lowest common multiple will give you that information too. So let me first talk to you about what a multiple is. So let's start with explaining a multiple. So a multiple is just a nice fancy word for counting by a number. So if I were counting by 6, that would be its multiples. So we'd have 6, 12, 18, what's next? Yep, 24, and then 30, and on, right? These are the multiples of 6. They're the numbers you land on when you count by 6. So if I'm given more than one number and I need the LCM, the lowest common multiple of those two numbers, what they want me to do is find the lowest point at which those two numbers, when you're counting by those two different numbers, meet. So let's say they gave me the number 6 and 8. So I counted by 6 already, 6, 12, 18, 24, 30. These are all the multiples of 6. Well, not all, just to there. There's a whole lot more, you know that, right? It goes on and on and on forever. I don't want to go on and on forever, so I'll stop, ... Let's count by 8 then. So 8, 16, 24. Oh, and looky here, because my goal is to find the lowest point that they match, that they have in common. And so they both reach 24. That's the lowest number that they have in common. So that is my lowest common multiple. The book gives us 3 ways to find that. And actually there's tons of ways. Like you'll see as you go along in school, you'll find teachers who found a different way to do it. They think theirs is easier because everybody thinks differently. So I have a tool that I use that the book doesn't show you, and because you're learning 3 today, I'm not going to throw that one at you, but everybody kind of shows you one, and at some point you'll be like, I like this one best. So I'm going to show you the 3 ways the book shows you how to find LCM. You use the one for your assignment that you feel like makes the most sense to you. So the first way is simply to list the multiples like we just did. We counted, if we wanted the LCM of 6 and 8, we counted by 6 to get its multiples, and we counted by 8 to get its multiples, and we found the lowest point at which they meet. So the LCM of 6 and 8 is 24. And so that's one way you can do it. Sometimes that's a pretty easy way. Sometimes it is tedious. It just goes on. The numbers go on before you find one that meets, but you can use that anyway. So that's one way. And there will be other meeting points along the way that these two numbers meet up at. This is just the lowest of those meeting points, the first one of those meeting points. So another tool that I've seen math teachers use is a Venn diagram. And this actually utilizes the tool that you used in the last lesson to do the prime factorization. So it allows us to use that tool to help us find the LCM. So if we were still finding the LCM of 6 and 8, first I would go ahead and find the prime factors of 6 and the prime factors of 8. So I give it the branches. And what numbers makes 6, 2, and 3 do? Is 2 prime? Yes, circle it. Is 3 prime? Yes, circle it. How about 8? Well, 2 times 4 equals 8. Is 2 prime? Yes, circle it. Is 4 prime? No, give some branches. What makes 4? 2 times 2 is 2 prime. Yes, circle it. Is 2 prime. Yes, circle it. So now that I'm all the way at my primes, what I'm going to do is I'm going to identify the ones where there's a shared one. So I noticed that this guy has 1, 2, and 1, 3. This guy has just a bunch of 2s. Well, we do have matching 2s, right? So that is a shared one. So here's how I will mark it in my Venn diagram. This is the numbers, for the primes for 6, and this is the prime factors for 8. The shared one, here and here, I'm going to just join them together where it in the shared section and just put it once there. They are shared, and there they are. The unshared ones that didn't have matches otherwise will just go on the outsides like that. So the 3 goes over here, the 2 from this over here goes there, and the 2 from this also goes over there. Now all I have to do is take all of these factors and multiply them together. So I'm going to do a 3 times 2 times 2 times 2. And you might be thinking, Miss Sanchez, why did you not just multiply all these? Remember that shared one? We couldn't count them twice. We would have counted them twice. We can only count it once. That's why. Okay? So then I get 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. The LCM, as we already knew from the previous one, the LCM of 6 and 8 is 24. It's the first point at which those numbers will meet when you count by both numbers. That was the second way they showed us. The third way that they show us is, I just called it line up the factors. This is actually a new one to me. I haven't seen it until I started teaching out of this book. It's just another way. And some of you might like this way better. So let's see how this one works. So if I want to find the LCM of 12 and 18, let's say, 2 different numbers this time than we did in the previous ways. Again, I'm going to utilize my skill that I learned in the previous lesson of getting prime factors. So I'll do my prime factorization of 12, and I will also do my prime factorization of 18. So starting with 12, let's see, that could be 2 times 6. 2 is prime, but 6 is not. I can do 2 times 3 to get 6. 2 is prime, and 3 is prime. For 18, I can do 2 times 9. I might have done 3 times 6. Either way, I'm going to get the same answers. So 2 is prime, 9 is not. And then 3 times 3 makes 9. 3 is prime, and 3 is prime. So now what I'm going to do is I'm going to take those primes, the prime factors for 12, as well as the prime factors for 18. And I'm going to line them up, but they can only be one above the other if there's a match. So for 12, I had the 2, 2, and 3. The 2, 2, and 3. Okay? Then for 18, I have the 2. And remember, just like in that lesson before, we went from smallest to biggest when we listed them to keep it organized. And this is why, because it helps you in this case. So we have 2, 3, 3. So let's put the 2, 3, 3. But we'll only put them under numbers that match them. So I have a 2 that matches that. I cannot put the 3 here because that's not a 3. It's got a match. So I'm going to skip that and go to here. And then the other 3 doesn't have a match. Okay. So I've lined them up with their matches. And now I'm only dropping one of the numbers from each row. So I would go to one of the 2s. Then there's, I'm going to draw an arrow there. Then there's this 2 that comes down. And I'm only using one of the 3s. And then a 3. And then I just multiply those together. Similar to that Venn diagram, right? We just took the shared numbers and only gave one of them. Shared numbers only gave one of them. It's just another way of looking at that same situation. 2 times 2 is 4. 4 times 3 is 12. And 12 times 3 is 36. So the LCM of 12 and 18 will be 36. So there's 3 ways to do it. We can practice more of those in our tutoring time or in our workshop classroom if we need to, but hopefully this helps get you through as you start getting the hang of it.